it says, what is this expression equal to? I just want to get in your head that the square root of x squared is the absolute value of x. Because if I plug in any positive number, like positive 2, if I plug that in for x, 2 squared is 4, the positive square root of 4 is 2, and so we get 2. Now remember, we're not taking the square root of both sides of the equation here, so there's no plus or minus. This is the principal square root, so this is the positive square root. We're going to talk more about that in a later chapter. Also, if I plug in negative 2, then if you square the negative, it's positive. If you take the positive square root, it's positive, it's 2. So if I plug in positive 2, I get out positive 2. If I plug in negative 2, I get out positive 2. And this would have been true with any pair of positive and negative numbers that are negatives of each other. And this is, that's what absolute value is. Okay. So now, is this function a relation? There's two ways we can do this. First is you can use what we just discussed. Well, first off, is it a relation? You can actually just plug in numbers and you can see like, oh, if x is 1, then what do we get? We get 1 squared equals 4 times y squared. And clearly this has two solutions, because when you take the square root of both sides of this, you're going to get y equals plus or minus 1/2. So we've got one x value that pairs with two different y values, and that's enough. So if you just need to prove that this is or is not a function, just show that 1 comma 1/2 satisfies the equation, and 1 comma negative 1/2 satisfies the equation, and you're done. Okay, but when you want to graph it, it can be a little tricky. There's a couple of ways you can do this. The proper way by definitions is what I'll kind of start to explain, and then I'll show you the shortcut that is equivalent to it. I've even kind of hinted at it in what I already mentioned. So x squared equals 4y squared. First thing is you could take square roots of both sides. Take the square root of both sides. Now, if you take the square root of both sides, technically, this is absolute value of x equals to absolute value of y. Because I'm taking the square root of 4, the square root of y squared, which is absolute value of y, based on this rule. Square root of x squared, absolute value of x. Now, you can break this into multiple cases. You could rewrite this as absolute value of y equals 1/2 absolute value of x. And remember, this breaks into two cases. If y is positive, so let's assume y is positive or 0, then we have y equals 1/2 absolute value of x because the absolute value is doing nothing. And if y is negative, by the definition of absolute value, we have negative y equals 1/2 absolute value of x. Now, it may be nicer and easier to just write that negative on the other side of the equation, like this. And we have two graphs that aren't too bad to graph if you know your absolute value graphs. One half x squared. Now, normal absolute value has a slope of 1, and over here it has a slope of negative 1. But if I put a half in front of it, it makes the slope a half and negative a half. So I can just erase this and go 1, 2, 1, just like this. 1, 2, 1. And this is y equals 1/2 absolute value of x. And does it make sense? Yes, because we've graphed it for where y is greater than or equal to 0. And that means all the y values above the x-axis, all the points that are above the x-axis that satisfy this inequality, or this equation, so we're good. Now, what about the equation on the bottom? It's actually just the same graph flipped over the x-axis, so it looks like this. And that's it. We've graphed it. Another way you could have done this, and just let me clarify one thing. The points that I just plotted on the picture are the coordinate pairs that satisfy the given relation. One example is 1, 1/2, which is right about there, 1, 1/2. And 1, -1/2 was the other one we found numerically. You put in 0 and find that it's 0, 0. And any point that's on this line, this line, this line, this line, every point that's on all those rays will satisfy the equation. The other way, and this is a shortcut you may know, is when you take the square root of both sides of an equation, you need to consider the plus or minus cases, and you don't need the absolute value. It's equivalent. The absolute value actually justifies why the plus or minus on both sides works. We get x equals plus or minus 2y. Now notice I'm not writing the absolute value. It's a shortcut and it's equivalent. And so what we end up with is, because if both of them have plus or minus, then if we have plus or minus on this side and we don't have the absolute value, it's equivalent to when we strictly use the rule and then split it up into the two cases. Do you see how we end up with the exact same graphs? We will end up with the exact same graphs, but it looks a little different in this case. So you could have, there's two cases here. So we would get y equals 1/2 x and y equals -1/2 x. And do you see that? This line is this one, and this line is this one. Either of these methods on this example work because this is a quadratic. And so we've shown that you can, and in class we've also done this, we've shown that you can just kind of plot points, like plug in x's and figure out what y's work. That could be a little longer. Or you can try to do some algebra to get y by itself and use the rules we learned about absolute value.